Okay. Hi, everybody. My name's Brian. I work on Spring.js at Pivotal. I'm also Cujo.js co-lead along with John Han. And I'm here to talk to you today about something you might be familiar with, AOP, but in a way that you may have never seen it before or a way you may not have thought was possible. And that's doing it in JavaScript and doing something pretty interesting with it in JavaScript. And so if you haven't used AOP, we're going to go quickly through a real brief refresher on what AOP is and what it does and kind of how it works. But I figure a lot of people in the audience have used AOP through Spring. How many people have used AOP either through Aspect-J, Spring AOP? Great, okay, cool. So we won't spend a ton of time on that. We're going to talk about how you can do it in JavaScript, and it's easy, it turns out. And then we're going to talk about my true ulterior motive of giving this presentation, which is to talk about something called application composition. So AOP, if you look it up on Wikipedia or some other sources, you kind of get a definition that looks like this. It's a program transformation that combines separate and possibly unrelated concerns. You're like, what does that mean, right? Sounds kind of cool, but I don't know what that means. So the way I tend to think about it, and this may be just as confusing, but is a way to non-invasively augment or modify the behavior of existing code. So if you've used Spring AOP or Aspect-J, you know that sort of you can have some existing classes even if they're compiled down to bytecode, and you can add new behavior to those classes without changing their source code. So that's sort of your mental model of what AOP can do. And AOP falls into this class of things that you might call composition strategies. It's a way to take different pieces of code or different behaviors and combine them to make an application. And one common approach to doing AOP is called advice. So you've seen Spring AOP, Aspect-J before, around, after returning, those kinds of advice. And Spring Framework internally uses AOP a lot to do a lot of its really neat stuff like transaction delineation, right? That's all done through AOP. And these are kind of the stereotypical examples of how you might use AOP, things you can do with AOP. Logging, because you don't want to include logging code in your classes. You want to be able to turn it on and off without paying the hit of doing the check to see if logging is on or off. You don't have these if statements in your code. So you'd like to be able to do these things in a different way that's non-invasive. Profiling is the same way. And then there are these more advanced, more useful concepts like transactions, security, that really cut across an application, right? They are not particularly related to the functionality of your application, but they're necessary things. And so how do you include those in your application without polluting your code with them? And if you've used Spring Transaction Support, Spring Security, you know that they give you a very good way to apply these behaviors without actually writing code inside your controllers or your models or whatever. And there are other composition strategies, ones that are very familiar. Inheritance and delegation are two very prominent ones in the object-oriented world. If you come from a functional background, functional composition is also a type of composition strategy where you take behaviors and you combine them to make an application. And AOP falls into this category. But AOP can solve a different class of problems than these other composition strategies. So here's a quick example, right? Say you wanted to add profiling to all instances of some class that you have, right? Well, you could subclass that and add in some explicit profiling code inside the methods of your class, right? But does that really make sense? What if you've got a person class? What are you going to create, a profiled person class? I mean, that sounds like something, the TSA would do or something like that. But, it doesn't really make any sense to have a profiled person in your application, right? There's nothing in your problem domain, most likely, called profiled person. So it breaks the is-a mental model. It also means everywhere that you would have created a person object, you now need to create a profiled person object or profiled X. And potentially, you need to mock the profiler, or, in your unit tests, you have to account for that somehow. So you end up changing your unit test too. And then, when you start to expand that out to the rest of your application, you want to say, I want to add profiling to classes X, Y, Z, A, B, C, right? You just basically multiply these problems. So AOP can solve these kinds of problems in a different way. The idea is to apply this behavior from the outside without writing new source code. And the way AOP does this is very controlled and non-invasive. So it makes some guarantees about not breaking your code. And just like inheritance does, If you've seen AspectJ and you've used it, you've probably thought to yourself, holy cow, how does this work? This seems, I don't even want to look under the hood here. Yes, AOP can be pretty sophisticated. It can require some pretty heavy-duty machinery. And some typical approaches are to actually transform the source code before it's compiled. And if you know anything about the history of AspectJ, you'll know that originally this is how AspectJ worked. But now AspectJ works via bytecode transformation. So it can take compiled Java bytecode and weave in new bytecode into that to modify the behavior. And you can imagine it's very important that AspectJ makes some very strong guarantees to you about what it's doing to your bytecode so that it doesn't break your application by, inserting strange bytecode in there. Another way you can do it, and Spring AOP, at least as far as I'm aware, works this way through Java proxies. So they proxy a lot of objects, and the proxies allow you to do method interception. So you can intercept a method, add some new behavior by writing a new method, some new code outside of the original class that will be executed when the proxy intercepts a method. And another way to do it is if you have some sort of platform that has VM or runtime support for dynamically inserting code. And there's really not a lot of this in sort of the practical world of software engineering in the enterprise world. But it does exist. Okay, so kind of have a feel for what AOP is. I'm sure, a lot of people raised their hands. So we know what it looks like and how to use it in Java. What does it look like in JavaScript? How do we use it? Why don't we see it more often? Well, JavaScript as a language, it doesn't have proxies, so that's not an option for implementing AOP. ECMAScript 6 will have language level proxies, but they're saying we won't be able to use that in production until 2016, so that's a few years off. We don't have bytecode access, and we don't have VM level support for AOP. So we're left with a couple of options, and neither of which sounds really easy. One is to do source code transformation, and the other is to do AST transformation. AST is abstract syntax tree. So if you have a JavaScript parser that parses the JavaScript into an abstract syntax tree, you can perform more structured transformations on that abstract syntax tree than you can on source code. And you don't have to resort to things like regex parsing and things like that. But again, this all sounds pretty sophisticated. And JavaScript is, thankfully, a very malleable, flexible language. Now, some people say that that's a bad thing. Some people view it as a good thing. But it is what it is. JavaScript objects are mutable. Methods can be replaced. Properties can be overwritten. And so this gives us a basis for doing something, for doing AOP in a way that we wouldn't be able to do it in a language like Java. So here's an example. We've got some object, thing, and it has a method named method. And we save a reference to that method in this variable orig. And then we overwrite method with a new function. And this new function does some additional stuff. And then, if you came to John Hand's talk this morning, uses function.apply to invoke the original function in the context using this, which is, if you were there this morning, you saw about the dot operator. In this case, if you call thing.method, thing will be this, and pass the same arguments that are passed to this function. So this is a very simple, very JavaScripty, very dynamic, within the language itself, way to augment the behavior of a method. And this technique is called method replacement for obvious reasons. So, knowing what you know about Spring AOP, what would you say, what type of advice would you say that this most closely resembles? Before, exactly. When we call thing.method, before the original behavior happens, we're going to do some additional stuff, okay? And there's some interesting things about this, right? If do original stuff throws an exception, what happens? It propagates, right? And the original behavior does not happen. So exceptions will still propagate. That's a good thing. The return value is preserved, right? We return orig.apply. So we haven't changed the return value. So code that is calling this will get the same return value. That's a very important guarantee. And we can use this technique to do other types of advice too. So here's another one. Very similar, storing a reference to the original method and then overriding that method with a new one that does what we want. So same question. What type of advice does this most closely resemble? After throwing, yes. Who said that? Nice. Yeah, after throwing, right? So we're going to run the original method, and if it succeeds, just return the value. Nothing else. If it throws an exception, we're going to catch the exception, do some additional stuff, and then rethrow the exception, right? Not changing the behavior, right? Preserving invariance. And this is, even after throwing, this is what, 1, 2, 3, 4, 5, 6, 6, 7, 8 lines of code. Now, it turns out if you want to start combining these pieces of advice, right, you have to get a little bit more sophisticated, but not really that much more sophisticated. And we'll see examples of combining these advices in a bit. So method replacement, it's easy. You can do it in very little code manually without the help of a library. It's dynamic. You can actually do that stuff at runtime. And since you're saving a reference to the original, you could at some point put the original back, right, and restore the original behavior if you wanted to do that. It does have some cons. One is if you know JavaScript prototypal inheritance, there are properties that are on the object itself, and there are inherited properties that are on the object's prototype. And when you do method replacement, you can change you end up changing, sometimes taking a property that was on the prototype and actually putting it onto the instance itself. This is a little obscure, and it usually doesn't cause problems, but you can change, that can change if there is code in your application that depends on properties being in the prototype or on the instance, and it's checking that via has-own property. It can change things in very subtle ways, but that's pretty rare. The other thing is that with AspectJ and Spring AOP, and Java in general, because we have a class path, we can do things like class path scanning. We can do some really sophisticated things, like scan all of the classes in my application and only log the ones that have these characteristics, right? And AspectJ provides an expression language for expressing these types of queries against our code. And that kind of thing is more difficult to do with an approach like method replacement. And in JavaScript in general, it's harder to do because we don't really have a class path. We don't have metadata about our code that's been compiled down to bytecode. We don't have a lot of type information. So that kind of thing is harder in general. But we'll see how we can sort of deal with that a little bit later. Okay. So I want to take some of those stereotypical examples. Actually, I'd probably just take one of them and walk through some JavaScript code that uses AOP to apply them. And all this code and the slides and the example application that I'm going to show at the end are all in the same GitHub repo. There'll be links at the end. So there's a ton of code here in the examples. I'm not going to go through it all. I'm going to go through just a few sections of it. And then you can go to the GitHub repo. You can look at, there are several examples of profiling, memoization, logging, and how to do them manually, how to do them using some AOP libraries. And there's actually even an implementation of, a full implementation of AOP with before, around, after throwing, after returning in 50 lines of JavaScript, which is kind of cool to see. Okay, so we've got this thing, right? This is very similar to the code example I showed on the slides. And it's got a method on its prototype called doStuff. And it just checks the value of x, and if x is less than 0, throws an error. If it's not, returns x plus 1. Silly, but good for examples. And so when you run this example, it prints out sort of at stages what it's doing and what happens as a result. So what if we wanted to debug this thing, right? Maybe it's causing a problem in our application and we're not really sure what's going on. I'm going to print out some diagnostic information. Well, one approach would be to pop open our editor, open thing, go in, change the source code, right? Rerun the application, right? We do it all the time, right? Put console.log in there. Well, that method is about 4 lines. But to really annotate the method and all of its paths and get the arguments and the potential return values, I really had to butcher it, right? So you can imagine doing this several times across your application in different places. You might actually end up changing the behavior of the method, right? And rerunning your unit tests, and all of a sudden it passes, right? How can console.log make my unit test pass? Well, you might have made a mistake. And for example, line 16, I actually had to split, right, into 2 lines. So this is a non-trivial change to the code, right? I'm changing entire statements. I'm adding new code. So to be a good engineer, if I make this change, I have to rerun my unit tests. Okay, we can do better. One other option we might have is to actually go to the call sites, right? Where do we call thing.doStuff? We could do the logging there. That way we don't have to change thing. Well, that's obviously a problem because if we use thing throughout our application, we've got to find all of the places where we use it, and we've got to change them all to look like this. And then we've got to change them all back, or do a git reset or something like that, and hope we didn't have any other code that was changed. So this is really not ideal either. So let's use some AOP. Let's see if we can get the same kind of functionality, log the arguments, log the return value, log the exception, without actually changing things source code and applying the method replacement technique that we saw earlier. So we're going to focus on this first block of code. This is just like what we were doing in the slide, right? Save a reference to the original. This time I'm saving the prototypes method, and I'm changing thing.doStuff. I could change the prototype here. I'll talk about that in a minute. And I'm using the same technique I showed on the slide. This is before advice, right? Console.log and then call the original. So before the original behavior, log the method, log the arguments, excuse me. So I'm just going to log x, and then I'm going to use .call or .apply to delegate back to the original. Okay, and if I call this, it will indeed log called with 1. You can run it in Node. The instructions are in a README. You can run it. And I can take this further. I can save the new method, right? I've already replaced it once. Save that one. Replace it again. And do some after advice, right? After returning. After returning, even though the return statement's at the end. But you get the idea. We're replacing the method again with one that first delegates the original, logs something, ensures that the original return value is returned. I can even do it a third time and add the after throwing advice and say, okay, run the original. If there's an exception, log it and rethrow it. Okay, so without changing the original source code, I could put this code wherever I need to put it, right? And modify the behavior of thing. Now, I've just modified a single instance of thing here, right? Which may or may not be what you want. You could instead elect to actually modify thing.prototype.doStuff. You could replace, because prototypes are just objects, you could replace doStuff on the prototype with these same methods, and then everything that you create in the application will have this new behavior. So you could do this, fairly early in your code in some module that you load that's responsible for doing some AOP. And then without changing any of the other code, you'd end up, all the things would get logged. Okay, well, that was pretty good, but it seemed like a lot of work. So there are some AOP libraries in JavaScript, and there's one in this repo that's the sort of 50-line of code AOP library. And what they help you with is, 1, syntax, and 2, preserving these invariants so you don't make the mistake yourself while you're doing the AOP manually. So you don't need them, but I highly recommend them. So they let you do stuff like this. This AOP library that I'm using has a method called before. I give it the method that I want to advise and an advice function, and it will do the work for me of setting that up. And I can do that for after returning and after throwing as well. Okay, so if it is easy in JavaScript, why don't we see it more often? And I thought about this a lot, and I think there's really 3 reasons why. the JavaScript community is comprised of very different groups of people, a vast number of groups of people. It's a very diverse group of engineers. And a certain section of that of the JavaScript community doesn't necessarily have a formal background in engineering. They may be designers, and they may be writing JavaScript because now their clients are demanding it, or they see JavaScript as a way to deliver better results to their clients. So they don't necessarily have a software engineering degree, they don't necessarily have a computer science degree, they haven't necessarily been working on Spring projects for the past 5 years, and so they don't know that AOP exists. Then there's this group of people that I've found, and this is really interesting, is that they're doing these things and they don't know it has a name. And they don't know that there are invariants that need to be preserved and why that's important. But what they do know is that it's this really cool thing that they can do that saves them a lot of time and helps them get the job done. So that group of people has even written libraries to do this kind of thing, and without knowing it had a name, which is kind of cool. And then there's a group of people, maybe in this room, who know what AOP is and have probably even used it, but they don't know what it looks like in JavaScript or how to apply it, or even if it's sort of kosher to apply AOP in JavaScript. And so I think, there's probably more reasons, but I think this is a good summary of why we don't see it. But even so, like I said, it does exist. And I think it's starting to become a little bit more popular. Twitter, their new flight widget library, which is relatively new, uses AOP advice a good bit in binding certain things together. Dojo, of course, Dojo has done everything already, and they did it 10 years ago. But they've had AOP for quite a while, and it's sort of been resurrected and given more prominence in newer versions with this new module, Dojo Aspect. And in Cujo.js, we have an AOP implementation called Meld, which also supports all the advice types. This one JavaScript hooker, this is an example of a library that was written by someone who didn't know AOP had a name, but it's a really cool little library. DCL is a project by another Dojo person involved in Dojo. Okay, so we talked about AOP, and we sort of looked at an example of logging, talked about profiling, memoization, but we're building web applications, right? These are user-facing applications, and users do not care about how cool your logging is or how sophisticated your profiler is. Although they reap the benefits of those things, they really don't care, right? They don't care about memoization. They don't even know what memoization means. So if that's all we could use this for in JavaScript, this talk would be terrible, and you'd be sorry you attended. So what else could we do with AOP that is much more interesting than these things? Well, when we build JavaScript applications, a lot of times we have this mental model of MVC. Right? We have models, we have views, we have controllers, and these things need to collaborate in order to form a running application. So if you think back to the logging example, right? We had a console and we had a thing, and we wanted them to work together. And one way to do that was to change the source code, but another way to do it was to use AOP. So what if we had a controller and a view and a model, and we wanted them to collaborate, and we wanted to do that in the same way? What if we could use AOP to do that without specifically writing the code inside our controllers, models, and views, and thus incurring the unit testing penalty of having to mock all that stuff? What if we could use something like AOP to connect this stuff together and make real applications out of it? That sounds useful. So that's what I did. I wrote a simple application. It's basically just a product list and a shopping cart. It's ridiculously simple. And I wrote it 7 times in 7 different styles. So I wrote it in plain old JavaScript using delegation and inheritance. And then I wrote it using events. Event emitters are a common pattern in JavaScript. I wrote it using global pubsub. And then I wrote it using a couple of variations on AOP, different styles of AOP, different ways of applying AOP. So let's take a look at this application, and I'll walk you through a couple examples of it, and we'll see it evolve from very hard-coded, very hard to test, to something that I think you'll find is much more elegant. Okay, so simple application. As engineers, we love to draw box and line diagrams. So we're going to start here. We've got really 2 things in our domain, right? We've got a product list, maybe product also, but product list and shopping cart. Very simple. And then when we think about how we're going to make this application work, we might introduce something like a controller or a mediator, okay, that's going to have some business logic in it. And in our mind, right, these things are going to collaborate to make a real application. So on paper, we're going to draw lines between them, right? And this is going to be our mental model for building an application. And you've probably drawn 1,000 of these. I know I have. So let's take a look at the application and then take a look at one of the examples of how it's built with delegation. And if we have time, I think we do, we'll probably look at one of the other 2, the events and pubsub, because I want you to see how the application changed and what changed about it when I switched from delegation to events. And all the variations of this application are in the GitHub repo. There's a README in there, instructions how to run it. There's a tiny web server included based on Node. You just run the web server and then you go to a URL and that loads the particular variation of the application. You can play around with it. So first, I'm going to show you the app. This is the application. Like I said, it's really simple. So if you're coming to the board games tonight, you can stock up on stuff. But basically, you have a list of products over here, and what's in your shopping cart over here on the right. And you can click a button, add something to your cart, and the delay is actually, I'm simulating an XHR, right? This is client server. I don't have a real server, so I'm sort of simulating that. And hey, I want a beer to go with my How to Cheat at Chess book. Okay, so add a couple things to my shopping cart. I can remove them. Again, simulated XHR delay. Oh, I like this one better. All right. Yes. Okay, simple application. Got our box and line diagram. We've seen the application. Let's look at some code. Over here on the left, the vanilla directory, this is where the simplest version of the application lives, the one we just saw. And you can see there's 4 JavaScript modules. I'm using AMD here. You've probably heard a lot about AMD at this conference. I'm using AMD modules. And there's a main module which sort of bootstraps the application. And then there's a controller, which I called mediator in the diagram. There's a cart view and a product list view. And then there's some stuff over in this common directory, like domain models for the product list and for the shopping cart. And those don't change across all of the variations of the application. So this is our bootstrap. We load some modules, the product list view, cart view, the controller, and then we create instances of them. In the case of the views, we give them a node to render into. And then down here at the bottom, this is sort of where we draw our lines, right? The lines in that diagram, we have to draw those somewhere. And so we're initializing the controller, and we're passing in the cart, that's the model, and the cart view. And then we're initializing the cart view by passing in the controller. Okay, that sounds a little strange. Why does the view have a direct reference to the controller? And the controller have a direct reference to the view? Seems odd. And then we initialize our product list view, and also has a direct reference to the controller. Okay, that seems a little weird, but let's look at the code. Okay, here's our controller. It's got an initialize function, which we saw. We pass in a cart and a cart view, and we just stash those in properties so we can use them later. And then we've got these two methods. We want to add an item to the cart, remove an item from the cart. Pretty logical things you would want to do in a shopping cart app. And the way they work is they directly invoke methods on the cart and the cart view, right? So the way this works is I'm hooking up event handlers to the buttons, and over here in the product list, I hook up event handlers so that when a product is clicked, I'm going to do some lookups in the DOM, but then I'm going to call a method on the controller. The view has to tell the controller to add this item to the shopping cart. And back over here, I can see that it does indeed add an item to the model, and if that's successful, also add it to the view. Okay, it's not really all that important to understand how this all fits together, but the thing I want you to look at and think about is how would you unit test this? What would you have to mock in order to unit test this? You have to mock at least two things, right? The cart and the cart view. Okay, that's important. Remember that. And there's not a lot of code here, right? We have to mock two things for 10 real lines of JavaScript. I think we can do better. And it's sort of the same situation over here in the cart view. When I remove an item, it calls controller.remove here. So the product list view is calling methods on the controller. So in order to test that thing, we've got to mock the controller. To test the cart view, and we also have to do the same thing. We have to mock the controller. To test the controller, we have to mock the cart and the cart view. Seems like a lot of work just to unit test. So, right, really, instead of these nice separate components with white space between them on the page and lines drawn between them, what we've actually created is this. Right? There's no separation here, right? They have direct references to one another. In order to unit test, I have to mock just about everything. And now I thought, when I started this, that when I created the events version, that would help, right? That would decouple some of this stuff, make it easier to unit test, simplify the code. And what I found was actually the opposite. So let's look just quickly at the events version of this code. So in the events directory, same thing. I've got this helper make evented, which applies a standard JavaScript event emitter pattern to any object. And if I go and I look at the bootstrap for this application, I can actually see that it got more complicated. Not by much, But now there's 3 things being passed into controller.init. So that probably means the sirens are going off in your head. I have to mock 3 things in order to test the controller now. And if we look at the controller code, holy cow, right? It got bigger. How did that happen? Well, I have to deal with subscriptions now, right? So I've got this overhead of dealing with events. Now I could potentially abstract this somewhere, but the point is, it wasn't some magical thing that made all my code better, right? It didn't actually separate my models and my views and my controller. And I've got this, I had to add event behavior onto this object. And this is very common. If you've used Node, there's an event emitter module in Node that does this very thing. It allows you to turn anything into an event emitter. And so I've got now a dependency on this function that makes things into event emitters. So, I at least have to provide some sort of no-op or something for this module, make evented, in order to unit test this thing. So it actually made things worse. The pubsub actually helped. I was surprised it did help, but not as much as I thought. And the problem with pubsub, without getting into the code, was it introduced a dependency on the pubsub library itself. Right? I wrote just a very small pubsub library to go along with this. But when you use pubsub, typically what will happen is you end up, right, importing in Java, or requiring, if you're using JavaScript modules, the actual implementation of a pubsub library. So now, right, you've got a dependency on the pubsub library. You've got to account for that in your unit testing. So it really wasn't a win to introduce events or pubsub. So like I said, what we really ended up with was this, and in some cases, unfortunately, what we end up is something that looks more like this. And when we start doing that more and more, we end up with an application that looks like this, right? Where is the product list in this diagram? Where is the shopping cart, right? They become entangled with everything in your application. And a change in one spot in your application has this ripple effect across to other things, and they break in ways that you didn't anticipate, and it is impossible to see when you're working on one part of the application. It also becomes much harder to unit test. So this is bad. We want to do something better for all these reasons. So that brings me to, like I said, my ulterior motive in talking about AOP, which is a way of applying AOP and using it to build applications that are more loosely coupled than you get with events and pubsub used in the way that I was using them. Pubsub is one of those things where when the JavaScript community found out about it, they started using it for everything. And so there's nothing necessarily wrong with pubsub. And in in the Java world, pubsub is used to great effect. So when used appropriately, it's a very powerful thing, but it is not the silver bullet, right? You can't use it for everything. So we think there's better ways to achieve this. So this notion of application composition, I don't know if you've heard that term before, is really the act of taking components and assembling them into an application. And this turns out to be a fairly different activity than implementing the logic inside of a component. Now, what has tended to happen is we've mixed those two, right? You saw it in my code, right? Implementing the business logic involved also hooking up things together, right? I was directly calling methods on other components. So I was mixing those two things together, but really they are fairly different kinds of concerns. And so this idea I want to sort of impress upon you is that there can be this notion of explicit separation between these two things. There can be components that are independent, testable, refactorable, and then there can be this place that you have for bringing those components together into a running application. And this matches up really well with Spring's application context notion, right? We tend to write classes that are very unit testable, right? Don't have a lot of dependencies. And then we use Spring Java config or Spring XML or whatever to bring those together and make an application. It'd be great to do the same thing in JavaScript. So the problem with our previous picture, where we had 3 boxes and lines, was that no one owned the lines, right? There was no place to put the lines. So we just sort of put them wherever we thought they belonged. The idea of a composition plan is the composition plan owns the lines. That's where you put the lines, right? Let's give it a real place. They are just as important many times as the components in your application, so let's give them a place. So I wanted to then take this idea and apply it to the application. Rebuild the application using this notion of application composition and attempting to use AOP as the implementation mechanism for it. And so I took the simple AOP library that's in the GitHub repo, and I rewrote the application. And let's take a look at that. I'll run it for you real quick. I think this is right. Yeah, okay. And this is going to be really boring because it just does exactly the same thing as the other application. They all behave the same way, which is what I wanted. Okay. All right. Let's look at the code. Okay, got the AOP simple directory over here. And again, I've got a bootstrap file called main.js. Let's look at that. Now, the first thing you're going to notice is this file is longer. Okay, we'll see why. The top is basically the same, loading all of our modules, creating our product and cart model, all the same stuff. But when we get down here to the bottom, things start to get interesting, right? Instead of, let's look at the bottom first. Instead of lots of dependencies being passed into the init methods, right? There's very few, and they kind of make sense, right? The controller has a reference to the cart model because it needs to add items to the cart. Kind of makes sense. The product list view has a reference to the products model, the product list model, because it needs to display the product list. So these dependencies down here, they make sense. And then we're using advice to link methods on these various objects. And I'm going to focus on this middle one first. Product list view has a method called product added, and I'm using after returning advice to say, after the product list view signals that a product has been added, tell the controller to add an item to the cart. Call add item to cart on controller. Now I'm using ES5 syntax here with function.bind so that I can create a function that will have the correct context. I'm not sure how many of you have seen that. This is standard JavaScript syntax. I could wrap this in an anonymous function and achieve the same goal. This is just a little nicer and shorter, taking advantage of ECMAScript 5 functionality. So without even looking at the controller source code, right, we've managed to connect a click on the product lists button to the controller's add item. Now let's look at the code. Let's see how this works. Let's look at the controller. Whoa, okay, that's a lot simpler. It has a reference to the cart. We saw that being passed into the init method. We're stashing that in a property. And then when we're told to add an item to the cart, what do? We just add the item to the cart. Easy. When we're told to remove an item from the cart, same thing. We do the obvious thing. And we do only the work that the controller should be concerned with. Okay, same question. How hard or easy is it to unit test this? You only have to mock one thing, right? So it got easier, and this code, not a lot of branching in this code, right? Very simple code. Let's take a look at the product list view. And if you remember from the other examples, I know I went through them quickly. This code was calling a method directly on the controller, and it doesn't even know about the controller now. So when it gets an event, and this is sort of an interesting concept, it calls a method on itself. And this is an interesting way to use AOP. You can use methods as events, right? There's this method on the product list view that it itself calls, which signals that a product was added. And if we look back at our composition plan, I'm saying via AOP, when the product list signals that a product was added, tell the controller to add the item to the cart. So the binding between these two components now is done externally to them, right? They can be unit tested independently without each knowing about the other and having to mock the other. And we can bring them together here in a dedicated place, right? That makes those components much more reusable also. There's another variation here in the AOP meld directory, and you can run it in a similar way, that uses Cujo.js's meld AOP library to achieve the same thing. Now, I'm not going to spend a lot of time on it, but what I want you to notice is there's no controller, there's no cart view, and there's no product list view module in this directory. There is, however, a composition plan, main.js. And if we look at that, it roughly looks similar to the one we just saw. It's using meld, so the syntax is a little bit different. It's actually a little nicer, a little more compact. You can see down here, it's a little more explicit, right? After the product added method of product list view returns, call controllers add item, right? Okay. Now, the thing I want the takeaway here is that this version of the application uses the same modules as the AOP simple version. No changes required. Now, the reason that can happen is because they aren't entangled with one another, right? I was able to change the way they're connected together without changing the modules themselves, right? And you should be thinking to yourself, no unit test changes, right? This code in controller could not have been broken because I wrote this new composition plan, right? And this opens up a lot of possibilities, right? If you have a bunch of reusable components, you can assemble them into application A, and then assemble them into application B, and then assemble them into application C without changing them. That's a very powerful concept. And it's something we've been talking about for years in software engineering, right? Reusable components. But you know, there are ways to do it, and this sort of achieves that effect. So this feels better, right? The components have no knowledge of one another. We could write a new composition plan using an entirely different AOP library, and still the application works without changing the source code of the components. We didn't have to re-unit test everything, right? We know when we don't change source code that there's not going to be regressions. So that's a good thing. And like I said, you can actually end up building application variants more quickly. So if this is something we can do using AOP, and there are structured ways of doing it, your engineer's brain should be saying, can't we wrap this up in a DSL that makes it even easier to do? And yes, we can. So I've created 2 more variations of the application that use more facilities of Cujo.js. And I want to walk you through an example of those. I did 2. The first one exactly mirrors the application behavior that you've seen so far. It's basically a direct port of the application to use Cujo.js. So we'll run that one. And again, it's pretty boring because it just does the same thing, behaves the same way. But what's really interesting, like we saw with the meld version, I was able to reuse the same components again. So this is now the 3rd iteration of the application, starting with the AOP simple version, where I didn't have to change any of the source code of the original components. So let's look at main, and this is going to look very different. The first thing you'll notice is that this is a JavaScript object literal. This is just an object. It starts up here, and it ends down here. So this is, all JavaScript is imperative, so this is going to execute, but really you can think of this as declarative. And we're using Cujo's IOC container, wire.js, to process this file, and it works a lot like Spring's dependency injection support, right? If you're familiar with writing an XML application context, this is a very similar type thing, only using something more native to the JavaScript language, just a JavaScript object literal. So we've got a controller up here, we've got a product list view, and we've got a cart view. We've got a products model and a cart model, all the things that we were creating in the other versions of the application, right now done declaratively. But we see these after returning, and this one that looks a little bit different up here, after fulfilling, may never have seen that type of advice before. I'll talk a little bit about that. But if you remember from our previous version of the application, the ones that used AOP, we were binding our product list view and our controller together using after returning advice, right? That's how we were drawing the line. And so here, we've done the exact same thing, right? We're saying after product list view's product added method returns, call controller.addItem. Pretty simple. Same thing down here. We've got some after returning advice down here, similar to the other versions of the application. Now, up here, after fulfilling, who's heard of JavaScript promises? Promises. Yes, okay, cool. Promises are a way to manage asynchrony in JavaScript, and they are much better than callback hell. So, if you've used them or if you're just being introduced to them, I highly recommend you check them out. We have a promise implementation in Cujo called When. There are plenty of popular promise implementations that all implement the same standard, promises A+. So I would say pick one, start using it. But promises have a notion of capturing the eventual outcome of an asynchronous operation, right? When you do an XHR, we know it doesn't return right away. In fact, it doesn't return anything, right? You have to pass it a callback function. But if you have a promise-based implementation of an XHR library, the implementation will return to you a promise immediately. And at some point later, that promise will either fulfill, meaning it succeeded, or it will reject, meaning it failed. So that represents the two possible outcomes of the XHR. And so because it returns something, it returns a promise, we can actually do AOP on that. So Cujo, through the IOC container, through wire, which is a highly asynchronous IOC container, provides an extra set of AOP advice types that operate on promises. So when we're talking about client-server applications, we're talking about doing REST calls to a server, we normally would think, well, I can't use AOP on that kind of thing. But it turns out we can. So we can create asynchronous connections, asynchronous lines between components using advice that looks very much like regular after returning, after throwing, after advice, but it's totally asynchronous. Okay, cool. So let me go back now. Oh, sorry. Here. And let's think about another scenario. We've got this application, and no application is ever done, right? Product manager comes to you and says, oh my God, users are getting confused. They don't understand that when they click the button and there's a delay, they're clicking the button again, right? They don't understand that the item's being added to their cart. It's causing problems. Or they have some other feature that they want you to implement. One thing that this kind of approach can allow you to do is add new behavior into your application without modifying your existing components. Okay, so just like we were able to take two existing components and marry them together using AOP, we can introduce new components and add those to the application in a non-invasive way without changing the source code of existing components. And again, no need to reunit test those components. So I'm going to load this application. This is the Cujo.js 2 application. And initially, it looks the same. But when I add an item to the cart now, oh, I get these little notification banners, right, that something's going on. Yeah, I know. They're not that snazzy. But this sort of represents some new functionality that you were asked to add into your application. All right, let's take a look at the Cujo.js 2 directory. And we've got a few more files here. And you can see again, we've got a main.js composition plan. It's written in the same style using the declarative IOC container. So it starts out looking the same. But we've got some other files over here. These are the files that implement that new functionality. Okay, they basically add and remove classes from to and from the DOM to make those messages appear. And they do. Let me show you one example. And they deal with timing, right? They show it for a little bit of time, and then they remove the class so that the message disappears again. So these three files, they're really small modules. Each one's a single function. These represent my new functionality, right? They might be bigger in some cases. They might be smaller in some cases, depending on what you're adding. But the important thing is, again, no controller, no cart view, no product list view. And you can even see, right in the code, I'm directly referencing the controller and the product list view from the other version of the application. So reusing them directly. So how did I add this new functionality in there? Well, I've got a couple of new components down here that I'm declaring, and they are basically instances of the modules, the new functionality modules, okay? Again, these are like spring beans. I've got a new bit of advice here on the cart model. I could have maybe chosen to do this on the cart view, but I chose to do it on the cart model. And it says, add around advice to the cart's add item method. Right? So now you can think about a waiting indicator, right? That's like the perfect case for around advice, right? While this method is running, show this waiting indicator. So that's what I'm doing here. I've got this component called adding item advice, which is a function right here. And I'm saying around add item, add some advice that runs this function. This is if we go and look at this module, adding item advice. It's if you've used around advice in Spring AOP, you know that around advice requires just a tiny bit of extra work, right? You have to deal with a join point and stuff like that. It's no different in JavaScript. So we provide join point support, things like that. So this is basically just a bit of advice that I wrote that uses wire and meld to run around adding an item to the cart. And it uses one of the other modules. But the effect is when the method is entered, it adds a class to the DOM. And then at some point later, when the method is done, it removes that class. And in fact, it deals with promises as well. So adding an item to the cart is an asynchronous operation. So it initially, right away, adds the class. And then after some time, when the XHR finishes, the around advice finishes, and it removes the class. And let me see where the other one is. Oh, anyway, that's it. So that's adding the new functionality to the application, and doing it in a non-invasive way. So inside the composition plan, I took my new code, my new components. I brought them in and created instances of them. And then I used around advice to add the new functionality to an existing module, the cart model, that was already there in the application. So no need to re-unit test everything. We know we didn't cause any regressions in the controller, the cart view, or the product list view because we didn't change the source code. Another interesting thing about this application, where's the controller? I'm going to scroll through the source code here. No controller. Okay, that's kind of weird. Let's look back at our controller from AOP Simple. This module is kind of ridiculous, right? What does it actually do? All it does is, it's basically an adapter, right? It's just an interface adapter, right? It takes a method named addItem to cart and turns it into a method named addItem. That's really all it does. So for a simple application like this, having a controller like this it doesn't make any sense, right? This is sort of unnecessary code. So after I wrote this, what I found is that I didn't actually even need it. So there's no controller in here, and instead I'm just using advice to sort of directly bind the components that the controller was mediating. I'm sort of using advice to directly bind them together. And in this case, it worked. This is a simple application. You know, in a more sophisticated application, you may not be able to do this kind of thing. But what tends to happen in MVC applications is we sort of get fooled into thinking that we have to have these things, right? And there's just no other way to do it. But when you have really simple stuff, sometimes all you have to do is link them together. But you still want to do it in a way that is non-invasive, testable, all that. So, you know, this was a kind of cool fallout of doing this, is that I didn't actually need that controller class. So I can delete it, I can delete its unit tests, and I don't have to worry about it. Okay. So we talked about a lot, saw a lot of code, but I want to quickly review the important points. And AOP is something that you're familiar with, but using it in JavaScript is something that you may not be. So I want you to take away from this that it is something that you can use. It is very powerful, and it can support this notion of application composition, where even when we're building JavaScript applications, which traditionally, you might have one giant JavaScript file or two giant JavaScript files. It doesn't have to be that way, right? You can have modules, you can have loose coupling, you can have unit testable, refactorable components, and you can bring them together in a way that you've been doing in Spring. You can do that in JavaScript and build real applications and get all the benefits that you get from doing it in Java, right? Build faster, reduce refactoring damage, all that stuff. So if you take anything away from this, if you don't remember how to do AOP manually, go look at the slides. But that's the thing I really want you to take away from this, is that you can build applications this way. All of the things that you know from working with Spring and other technologies like it, and all the things that you're used to doing on the server, when you start building these bigger and bigger applications in JavaScript, they still apply. They look different, but they still apply. Okay, there's a ton of links here at the end on AOP, AOP libraries. There's pointers to the IOC container and other parts of Cujo.js that I was using in those later examples. All the examples are there in the GitHub repo. You can also check out, we have some additional sample apps on node.cujojs.com, which is our documentation site. And there's also some tutorials there on various things. We have our first AOP tutorial up. There's likely to be a second one very soon. So if you want to read more about AOP specifically in JavaScript, keep an eye on that. You can go check out the first one now. Keep an eye out for the second one. And that's it. Questions? Yeah?
How much does it affect the testability of the components? So when you move things into the AOP main file,
Mm-hmm.
you put some more logic in there. How hard is it to test it there versus where it was before?
Right. That's a great question, and it also goes to the question of functional or compositional testing. And a lot of times when you're doing functional testing, what you're testing is the lines, right? Unit tests are really good at testing the boxes, and functional tests a lot of times test the lines. And you still have to do that kind of thing. And the same techniques for testing those kinds of things still apply. So if you want to use Selenium or Karma or other testing tools, to drive those kinds of tests, you can do the same thing. And what I didn't show here, and I should have mentioned, but you jogged my memory, is when you start building applications in this way, and you may have done this with Spring, is that you don't end up with one composition plan as the application gets larger. You might end up with several, and you might structure those hierarchically. In your mind, you could picture this as an application that has multiple screens, right? And each screen maybe has its own composition plan and is made up of many components, many larger grained components put together to form one section of your application. And then you do the same thing over here. And now you've got this larger unit, right, that has boxes and lines in it. And you could potentially write a test harness around that that's just enough to boot up that part of the application, and then write functional tests against that. So yes, you still have to do it, but luckily the same kinds of techniques, web drivers and whatnot, Phantom.js, that kind of thing can still apply. Yeah, great question. Others? Another one, yes.
Have you noticed a significant, so I'm fairly new to JavaScript, but have you noticed a significant impact in the way writing code like that is effective with the tools that you're using? I noticed that a lot of references to functions are all done by strings, and IDEs often can't interpret what you're trying to do.
Right.
So you lose a lot of auto-completion, but I'm just wondering if that is an issue or you haven't noticed that.
It is an issue, yes. I haven't found it to be a significant issue, but it is definitely an issue. And if if and when we see JavaScript IDEs become more sophisticated and the ability to do more sophisticated types of completions, it may become a larger issue. But I think as we've seen in the Java world with IDEs becoming aware of Spring XML files, becoming aware of Spring Java config and annotations and that type of thing, it's probably going to be that tools will also evolve on the JavaScript side to support that kind of thing. But right now, some editors, WebStorm in particular, will actually complete stuff inside strings. It's just sort of a happy accident. I don't think they intended it to work that way, but they will, but other editors won't. Yeah. So there is an impact. I haven't noticed it being significant though. Yeah.
For me, at least, one of the things that caught my attention is that on the product list, whenever we're returning item, without the AOP, that really doesn't do anything.
Right.
So basically, like for the component itself, that's simply something that's not actually accomplishing anything unless AOP is on top of it, which is an interesting way to look at it. Usually you think of AOP as something that will work on top of your existing functionality, but in that case, AOP is actually enabling that functionality.
Yes.
Right? So that got me thinking. I know that in Java we have a number of other features that can do the same or something similar to that, Spring, the basic functionality there. But is there any situation that would be applicable, maybe in Java itself? Instead of creating the relationships in Spring, maybe in certain situations we would prefer to express them in AOP instead.
Let me try to repeat that question. He made an observation that, a very good observation, that there was a case where in the product list view, I was returning something from a method, and in another version of the application, I wasn't returning anything, and I had to do that. I had to make a concession there to make the application work that way. So, it's not a panacea. I did have to make a concession there. But I think your question is, in other platforms, is it possible to use AOP to do some of the things that you rely on, aspect J to...
Or would it make sense to do that? Because what I was thinking here was that specific thing that you did there. Because basically we're returning a value that by itself wouldn't do anything, but with the AOP on top of it, it became significant. Like you said, it's like we're triggering an event. We're talking to AOP indirectly.
Yeah.
Would that make sense in Java or in some of the other languages?
I think it would. I mean, I think all of the concepts that are in this talk, a lot of them came from other languages, other platforms, and so I think in general the concepts are widely applicable. That kind of transformation of the code, subtle transformation of the code, could be useful in other cases, and there might be cases where you might want to do that kind of return for unit testing, unit testability as well. So it might not be a completely useless concession, outside of AOP. There might be cases where it's actually useful. Yeah. Yes?
How will these techniques work with other frameworks like Angular?
Great question. How well do these techniques work with other frameworks? It's something of a mixed bag. And the reason is, for frameworks that tend to deal with plain JavaScript objects, constructor functions, prototypes, things like that, they work great because that's all we're relying on is language level things that are there, for us. In certain frameworks that like to provide different kinds of interfaces to their functionality. And a good example of this is jQuery UI. At least parts of jQuery UI don't expose plain old JavaScript objects. They expose special objects that have a different kind of interface. There are some, for example, some jQuery widgets, instead of calling a method directly on the object, the widget object that you can try to get your hands on, you call up the name of the widget, a method named after the name of the widget, and pass as a string the method that you actually want to call on that thing. So when you have situations like that, it's a little more difficult to apply AOP generically on those types of things. Now, in ECMAScript 6, there are going to be language level proxies. And in wire.js, we don't have language level proxies, obviously, but we do have a proxying infrastructure that allows us to apply advice in an implementation specific way. So, once you have proxying, you can have a proxy that knows how to add advice to a jQuery widget, for example. So what I think, in the future, what will happen is we'll see ECMAScript proxies used more widely for stuff like that. Yeah, good question. Yes?
The before advice that you showed earlier, if I have to implement it using, like, for example, for caching, is it possible for the before advice to exit the whole method without executing the original method you intended to put your aspect with?
Sure. The question is, on the before advice example, could you use that to implement caching or memoization? Look in a cache for the value, exit early, and return the cache value. Typically, you will use around advice for that kind of functionality, and that's fairly typical for Aspect-J and Spring AOP too. Spring usually around advice is the only way to actually prevent the original method from being executed. And then you do that by simply not telling the join point to proceed. So you look in the cache, get the value. If it was there, just return it. If it wasn't there, tell the join point to proceed, get the result of that, stick it in the cache, and then return that. And there's some examples of that in the GitHub repo. There's a memoization example that shows that. Sure. Any others? Okay, thank you very much.